Hello, this is Mr. Young, and welcome to Lesson 3.7, Melting and Freezing. Before we begin, please take out something to write with and something to write on. You will need these notes. Hello, this is Mr. Young, and welcome to Lesson 3.7, Melting and Freezing. Before we begin, please take out something to write with and something to write on. You will find these notes useful on assignments, labs, and assessments. By the end of this lesson, you should be able to explain what happens to the motion, arrangement, and average kinetic energy of water during a phase change. During an endothermic change, the system absorbs energy from its surroundings. Melting is an example of an endothermic change. 1 gram of ice absorbs 334 joules of energy as it melts. The amount of energy is the heat of fusion for water. The heat of fusion varies from substance to substance. Strange as it may seem, during a freeze, Florida orange growers will spray water to protect the crop. The reason is that 1 gram of water releases 334 joules of energy to its surrounding as it freezes, the same amount of energy that absorbs when 1 gram of ice melts. As water freezes, it releases heat. The flow of heat slows the drop in temperature and helps protect the crops from damage. During an exothermic change, the system releases energies to its surroundings. Freezing is an example of an exothermic change. Each water molecule contains 2 hydrogen atoms and 1 oxygen atom. In ice, attraction between the water molecules keeps the molecules in fixed positions. Any energy gained by the water after a phase change increases the average kinetic energy of the molecules, and the temperature rises. When ice cubes are removed from a freezer, heat flows from the air into the ice. As the ice gains energy, the molecules vibrate more quickly. At the melting point of water, 0 degrees Celsius, some molecules gain enough energy to overcome the attractions and move from their fixed positions. When all the molecules have enough energy to move, melting is complete. Often people think of cold temperatures when they hear the term freezing, but substances that are solid at room temperatures freeze at a temperature that are quite high. For example, silicon freezes at 1,412 degrees Celsius. That's 2,574 Fahrenheit. Any energy removed after the freezing is complete decreases the average kinetic energy of the molecules, and the temperature continues to drop. When liquid water is placed in a freezer, energy flows from the water to the air in the freezer, and the water cools. As the average kinetic energy of its molecule decreases, they move far more slowly. At the freezing point of water, some molecules move slowly enough for the attractions between molecules to have an effect. When all the molecules have drawn into an orderly arrangement, freezing is complete. When all molecules have drawn into an orderly arrangement, freezing is complete. By now, you should be able to explain what happens to the motion, arrangement, and average kinetic energy of water during a phase change. We hope you enjoyed our lesson.